So this is my explainer video for the conservation of energy problem on Expert TA. It's number 3, part B. Problem states, a student pushes a baseball of M equals 0.19 kilograms down onto the top of a vertical spring that has its lower end fixed to a table, compressing the spring a distance of 0.18 meters. The spring constant of the spring is 710 newtons per meter, and it says let the gravitational potential energy be 0 at the position of the baseball in the compressed spring. And then it's asking us to solve for, it says what is the maximum height in meters that the ball reaches above the equilibrium point. So when this spring gets pushed down and the ball is let go, it's asking how high is it gonna be able to reach after being released. So what do we know? We know that M is 0.19 kilograms, the mass. We know that the spring constant is 710 newtons per meter, and we know that the distance of the compressed spring is 0.18 meters. So what can we use to solve? So when the ball reaches above its equilibrium point, and that's what it's asking us, like how high it's going to go after that, the kinetic energy is equal to the potential energy. So we can also write this as 1/2 times the mass times the velocity squared is equal to the mass times g times h. So to solve define h, what we're looking for, the maximum height, or like the most distance that it's going to go, you use algebra to rearrange the equation, and it would eventually be set equal. It would be h equals the velocity squared divided by 2g. So to solve for this, you need to know the velocity. It's not given in this problem, but in part A of this problem, you would find the velocity to be 10.84, which meters per second, which we can use to plug this in along with what we know to be the constant of g to solve for the maximum height. So h would equal 10.84 meters per second squared divided by 2 times 9.8 meters per second squared. And this would give us a final answer of the maximum height of 5.995 meters, and you can write that to 6. And so that's how you find the maximum height. Some pitfalls to watch out for: just make sure you're using the correct equations, like plugging in the right stuff to set equal to your kinetic energy and your potential energy. Make sure you're using your right variables, like your known values that you're given in the problem. Just make sure you're doing that correctly and not mixing up the numbers. And then make sure you use your correct constants. Like G is the only one you needed in this. Just make sure you use the 9.8 to not mess that up. And yeah, then you'll be good.